2. So they give us 2 points of a line segment, and they ask us to divide it basically internally in the ratio of 1 is to 4. So there's a formula in your log tables for this. So it's b x1, so it's complicated enough little formula. Plus ax2 over b plus a. So that's it. And then the a and the b then are the there's going to be the ratio. So the a and the b, a will be 4 and b will be 1 for this one, and then we've got our x1, y1 and x2, y2. Those are the coordinates. So you just need to be careful here. It's a tedious enough little formula, so just be careful putting in everything. So you should get 1 times 8 plus 4 times minus 1 over 1 plus 4 then 1 times minus 4 plus 4 times 3 all over 1 plus 4 again. So you just need to use calculator then, and when you put all those in, you should get the 0.4 over 5, 8 over 5. And that's it. It's just following the formula. So what you've done is from A to B, so if you have point A and you have a point B, then you've divided it basically in a ratio of 4 is to 1. So that would have to be, the point then would have to be kind of around maybe here somewhere. So it's kind of 1/5 of the way across the line. So that's part A of the question. Part B then, the line L has a slope of m and contains the point QR. So they don't give us any of the numbers in this one. Find the coordinates of the point where L cuts the y-axis. So it's the equation of a line we need anyway. So let's just kind of work out what the equation of the line would be, and then you can, when you've got that, then you can let x be 0 to see where it cuts the x-axis or cuts the y-axis. So y minus y1 equals m by x minus x1. So we can give our answer in terms of m, q, and r. So we don't need to worry if there's m, q, m's, and q's and r's in the equation. So y minus and y1 would be r, because that's the point that's on the line. M times x minus, and then x1 would be q. So if you simplify out, or if you multiply out the brackets there, you get mx minus mq y minus r. If you bring everything over, you get so y minus mx minus r minus mq. Right, so that's the equation of the line really. It should be plus mq and equals 0. So we wanted where it cuts the y-axis. So everywhere that the line cuts the y-axis is the one going up. Everywhere on that line, x will be 0. So for example, 0, 3, or 0, 7. Those are all points that are on the line. So x is always 0 on the y-axis, so that's important. So if x is always 0, then you can just sub in a 0 instead of the x. So if you put a 0 instead of the x there, you get y minus m times 0. And I'm going to move those things over the other side actually for a second. So r minus mq. I'm just moving them back over because you'll see in a second. It's because m times 0, that will just be 0. So we just get y equals r minus mq. So you actually worked out what the coordinate will be then. So it'll be the point 0 r minus mq, because y is r minus mq when x is 0. And that's the point then, that's what it is. So for part C then, so the line K has a slope -2, and then the line J makes an angle. So you can see straight away it's going to be this formula where the tan theta formula in your log table. So tan of theta, whatever the angle is, equals, and it's to do with the slope, so m1 minus m2 over 1 plus m1 m2. So it's obvious enough. The question has got to do with slopes. It's the slopes of two lines, the lines K and the line J, and then it's the angle of 30 degrees, so it kind of suits this equation. So you know that tan, if you just sub everything in, tan of 30 has to be equal to, m1 is actually given to you. They tell you that m1 is -2. So we'll just sub it in. Sorry, it should be plus or minus there as well. So -2 minus m2 over 1 plus -2 times m2. Now tan of 30, you can use calculator or your log tables to figure it out. So it's 1 over root 3. So that has to be equal to -2 minus m2 over 1 minus 2m2. I haven't done much with that yet. You can kind of cross multiply here then. So 1 minus 2m2 equals -2 root 3 minus root 3 m2. So still got a bit of work to do to get m2 by itself. Let's just move over all the m2's to the left hand side then. So I'm going to move over the minus root 3 m2, so that will just be root 3 m2 and then minus 2 m2. I'm just keeping it that side, and I'm moving across the positive 1, the left hand side, over to the right hand side, so I get -2 root 3 minus 1. So I've just kind of switched the m2 and the minus root 3 m2 and the 1 on both sides and change the signs. Here then I can factorize out the m2. So m2, I take it out, root 3 minus 2 equals, and we still have -2 root 3 minus 1. I'm not changing the right hand side. And then to get m2 by itself, I just have to divide across by root 3 minus 2. So we get -2 root 3 minus 1 over root 3 minus 2, and then that's it. That's what m2 is. So we should be finished then really, but if you look back up the question here at this part, it asks you to give your answer in that form, in the form d plus e root f. So that's not in the form at the minute. What you have to do is you have to rationalize the denominator, so you need to look back at that if you're not sure. So what I'm going to do is I'm going to multiply top and bottom by root 3 plus 2. Right, so on top, so you're multiplying everything by everything then, so they're all kind of in double brackets So root 3 times minus 2 root 3 will be minus 2, so I would get minus 6 minus 4 root 3. So minus 2 root 3 times 2 is minus 4 root 3. Minus 1 times root 3 is minus root 3. And then minus 1 times 2 is minus 2. On the bottom we get root 3 times root 3 is 3. Plus 2 root 3 minus 2 root 3. Those ones will cancel out. They always will if we rationalise properly. Minus 4. So we get minus 1 on the bottom. And on top we're going to get minus 8 minus 5 root 3. What you can do then is you can times top and bottom by minus 1. And it'll just make the bottom into a positive 1, or you could just divide in the minus 1 anyway. So you'll get 8 plus 5 root 3. And that's everything then for that question.